Welcome everyone to The Explainer. Today, we are going to completely demystify a concept that literally powers the modern internet. I'm talking about virtual machines. If you've ever found yourself kind of scratching your head over cloud computing or how massive tech giants actually manage all their infrastructure, well, you are definitely in the right place. We're going to break this all down using a framework that just makes perfect sense. We'll start with something super tangible, like real estate, and then we're going to scale that all the way up to global cloud architectures. Let's get into it.
Okay, so here's our roadmap for today. 1. The core concept of efficiency. 2. The real estate analogy. 3. The physical server dilemma. 4. Enter the virtual machine. And finally, 5. Scaling to the cloud.
All right, part 1. The core concept, efficiency, which is the ultimate goal of DevOps.
Before I even touch the hardware side of things, we really have to talk about the mindset. You hear the word DevOps thrown around constantly in the tech world, right? Well, in the context of server management, DevOps is essentially all about one thing: improving efficiency and maximizing resource utilization. Whenever engineers are setting up automation or deploying new infrastructure, the absolute end goal is always pure efficiency. Keep that firmly in mind, because literally every technical innovation we're looking at today was born out of a desperate need to just stop wasting valuable resources.
Moving right along to Section 2, the real estate analogy, making the most of 1 acre.
Picture this. You have this beautiful, flat, 1-acre plot of land in your hometown. You build your absolute dream house on it. You're living there with your family, and it's great. But one day, you look out the window and realize something. You're living lavishly, sure, but you're really only using about half an acre. That other half? It's completely unused. Just wasted space. So what do? Well, you build a second property on that unused half acre, and you rent it out. This brilliantly illustrates a massive shift in thinking. By doing this, your comfort hasn't changed at all. You still have everything you need, but now a whole other family is living happily on that other half. They have their own water, their own space, and you don't interfere with each other whatsoever. You've taken this inefficient setup where 2 people lived on an acre and transformed it so 4 people can live on that exact same physical land without stepping on anyone's toes.
Which brings us to Section 3, the physical server dilemma, when Example.com buys hardware.
Imagine a company, let's just call them Example.com. They go out and buy a massive physical server from a manufacturer like HP. They install their main application on it so their customers can use it. But look at the massive inefficiency that happens here. Example.com bought a server with 100 gigabytes of capacity and 100 processors, but their specific app, it only actually needs 4 gigabytes of RAM and 4 CPUs to run perfectly. That means a measly 4% of the server is being used. A staggering 96% of that incredibly expensive hardware is just sitting there completely idle. It is exactly like that wasted half acre of land, but on a massive, highly expensive corporate scale.
Historically, companies would literally dedicate an entire physical server to one single team. Team 1 gets server 1, Team 2 gets server 2. You get the idea. The result of that? Devastating underutilization. Teams were leaving 90% or more of their server's capability completely untouched. In fact, this inefficiency was widely considered the biggest rock, like the absolute largest obstacle in IT infrastructure. It was just an incredibly expensive waste of processing power.
So how do we fix it? That's Section 4. Enter the virtual machine, logical partitioning.
To build our digital rental properties, we need a very special kind of software. It's called a hypervisor. A hypervisor is installed directly onto the bare metal physical server. Popular ones you might have heard of are VMware or Xen. Think of the hypervisor as the ultimate property manager. It's the crucial key that takes a single physical server and cleanly breaks it down into multiple, logically isolated environments.
Take a look at how this totally changes the game for Example.com. The hypervisor swoops in, takes that single 100 gigabyte bare metal server and cleanly divides it up. So instead of giving the whole bulky machine to Team 1, the hypervisor creates Virtual Machine 1 for Team 1, Virtual Machine 2 for Team 2, and so on down the line to Team 5. We've literally taken one server and logically turned it into 5. It's that exact same principle as renting out the unused half acre of land. We are finally using the space efficiently.
Now, it's super important to grasp what a virtual machine actually feels like to the person using it. Even though it's sharing the underlying hardware, a virtual machine functions as a completely independent computer system. It's got its own isolated CPU, its own isolated memory. They operate on logically separated hardware. Team 1's application absolutely cannot access Team 2's memory. They are totally fenced off from one another. And the best part? We achieve all this logical separation without physically altering the host server at all. The physical metal box just sits there untouched in a rack, while the hypervisor works all its magic purely in the software.
All right, Section 5, Scaling to the Cloud, the Global Data Center.
Whenever you hear the buzzword, the cloud, what you're really hearing about are just millions of these virtual machines being managed by hypervisors in massive data centers. Let's walk through the exact journey. Say, step 1, you log into Amazon Web Services and request a server. You want 10 gigabytes of RAM and you want it located in Mumbai. Step 2, AWS scans its massive warehouse of server racks and finds an underutilized physical server, let's call it server P100, that happens to have that exact amount of spare capacity. Step 3, the hypervisor on server P100 gets the command and dynamically spins up that logical virtual machine on the spot. And finally, step 4, AWS shoots you over an IP address in your security keys. Just like that, you have a computer ready to rock in Mumbai.
This transaction really highlights a profound shift in how we think about computing today. We're talking about the difference between physical ownership and logical access. When you rent a virtual machine from AWS or Azure, you're paying for the logical access. You get an IP address, you get your key value pairs, and you use the environment. You never, ever get physical access to the actual hardware. You don't own the bare metal. You can't stroll into the Mumbai data center and point at your machine. You only control the logical partition that the hypervisor carved out specifically for you. And guys, the scale of this efficiency is just mind-boggling. Think about it. Without virtual machines, an AWS data center with 100 physical servers could only serve exactly 100 customers. That's it. But because hypervisors chop those servers up into perfectly sized, isolated environments, those same 100 servers can serve thousands. And big data centers, they can serve millions of users simultaneously. It is quite literally the absolute peak of resource utilization.
But here is a really fun fact for you. This technology isn't just locked away in some mega corporation's data center. You can actually use this exact same efficiency trick locally. You can go install a hypervisor like Oracle VirtualBox directly onto your personal laptop right now. You could carve out a virtual machine, give it some of your unused RAM, and share it with a family member over your Wi-Fi. They could be remotely logged in, doing their homework or whatever on the virtual machine while you're sitting right there typing away on the base laptop at the exact same time. You're effectively running your own mini data center right from your living room.
So we've seen how logical partitioning essentially saved the entire IT industry from wasting 90% of its expensive hardware, allowing them to serve millions of users in the cloud. It is a true masterclass in maximizing resources. Which leaves us with a pretty interesting thought to ponder, doesn't it? Knowing how these logical partitions eliminated such massive physical waste globally, how much of your own hardware's capacity, your laptop, your phone, your desktop, is just sitting completely idle right now? Thanks so much for joining me on this explainer, and keep looking for ways to maximize your own efficiency.